Section 2.2 on polynomial functions of higher degree. So in section 1 we mostly looked at quadratic functions which were a degree of 2. That meant the exponent was the second degree or second power, however you want to say it. So first thing we want to look at is naming a polynomial. To name a polynomial, you're going to look at the highest exponent, which tells you the degree. So you could say second degree, third degree, fourth degree, etc. Most of the time, for a highest exponent of 2, we say quadratic. For a 3, we say cubic. Fourth, you could say quartic. Fifth, you could say quintic, but that gets a little confusing. So usually after 3, we just say 4th degree, 5th degree, 17th degree, etc. Then the next thing you want to look at is the number of terms in the polynomial. So a monomial is 1 term. A binomial is 2 terms separated by a plus or a minus sign. Trinomial is 3 terms separated by pluses or minuses. And then anything after 3 we just say polynomial or many terms. Next thing we want to talk about is the end behavior of the graph. And that just means what's happening on the ends of the graph. On the farthest left and right, what is the graph doing? And so you can think about what the arrows would be doing to help you out here. So a way to know by the equation what's happening on the ends of a graph is to look at the highest exponent and the sign of that term. Not the sign of the exponent, but the sign of the term. So if the highest exponent is an even number and the term is positive, then that means that the end behavior rises on the left and right side. So if you think about the graph positive x squared, we know that positive x squared is a U that opens up. And so it rises on the left and the right. If you have the highest exponent is even, but the coefficient is negative, then it's going to do the opposite. If you think about negative x squared is a U that opens down. So that means it falls left and right. Okay, so that's anything that's an even power. They're going to be doing the same things on the left and right. If it's positive, then it's going to be going up. Negative, going down. Okay, so what about when they are odd? So when the highest exponent is odd and the coefficient is positive, like positive x cubed, you remember what positive x cubed looks like. It's kind of that crazy S that goes through the origin. Well, it's pointing down on the left-hand side and up on the right-hand side. So that falls left and rises right. Overall, I think of it when it's odd and positive, like positive x cubed, that the whole graph is going up from left to right. So it's going to be the opposite if it's odd and negative. If you think about negative x cubed, then it's going to be doing the complete opposite. It rises on the left and falls on the right. So overall, the whole graph is going down left to right. Okay, so you just remember these rules. Look at the highest exponent and the sign in front of that term, and that will tell you what the end behavior of the polynomial is. Next, a function of n degree. So remember the degree is the highest exponent. Whatever that exponent is the number of real zeros for that polynomial. That's the most number that it can have. So if it's a third degree polynomial, that polynomial can have only 3 zeros. Can't have more than 3. It also has at most n minus 1 turning points. So if we're talking about x to the third power, 3 minus 1 is 2, so that means x to the third turns 2 times on the graph. So it has 2 times that it turns. Okay, real zeros on a graph. So if you solve a polynomial and you get x equals some number, that is called a root, a solution, and a zero. Those 3 words are used interchangeably. That also means that x minus a is a factor, and the point a comma 0 is an x-intercept. So those 3 things can be very useful when you're talking about the graph of a polynomial. Okay, next, repeated zeros. So sometimes a solution or a zero repeats whenever you factor something out. Might have the same number a couple of times. So that's called multiplicity. So if a factor, x minus a, repeats and it has some power, whether that's a 2, a 3, a 5, whatever that k is, that tells you the multiplicity, or how many times the zero repeats. So if that exponent is odd, so if it's x minus some number to the first power, then the graph crosses at that point. So it can be the first power, third, fifth, seventh, any odd number. That means it crosses at that point. It's going to go through it on the x-axis. But if that number is even, like 2, 4, 6, 8, then it's just going to touch at that point. So it's going to come up and touch the point and then go back in the opposite direction. So it doesn't cross, it just touches. So all of these things are going to help us if I can look at the equation of a polynomial and figure out all these things, then I kind of have a visual in my mind of what it's going to look like before I actually graph it. So let's go back through this and look at some examples. Let's start by naming a polynomial. So on part A here I have y equals negative 2x plus 3x cubed minus 5 plus x to the 7th. Now normally we would want to rearrange this in descending power, but for naming the polynomial I really don't need to do that. I'm looking at the highest exponent and the number of terms. So the highest exponent here is a 7 and it has more than 3 terms, so this will be a 7th degree polynomial, many terms. Let's look at another one. Y equals 2x squared plus 3x cubed. So the highest exponent is a 3, so we could call it a cubic function or a 3rd degree, and it has 2 terms, so that's a binomial. So you could say 3rd degree binomial or cubic binomial. Either one of those is acceptable. Okay, number 2, describe the end behavior. So if you're given an equation, negative 2x cubed plus 5x minus 1, and I want to know what it's doing on the ends of the graph, remember I want to look at the highest exponent and the sign of the term that that exponent is on. So for example, x cubed is the highest exponent, so that number is odd, and the sign in front of that term is negative. So odd and negative means they're doing opposite things on the ends, and it's negative overall. So that means that it rises on the left and falls on the right. Okay, what about 3x squared minus 5? So the highest exponent is squared, which is even, and that term is positive, so that means they're doing the same thing and it's positive, so they're both going up, so that's rises left and right. Okay, number 3, we're supposed to write a polynomial function with the following zeros. So sometimes they're going to give you some solutions and you have to come up with an equation that if you graphed it, it would cross through those points. Well, there's lots of possibilities. I could come up with a whole bunch of different equations that would cross through at these 4 points. But so that we all come up with the same equation, we're going to follow this process. Whatever those zeros are, you're going to set them each equal to 0 first. And then you're going to move that number to the same side as the x and write it as a factor. So the factors would be x minus 2 times x plus 2 times x minus 1 times x minus 3. So they just change signs when I put them in parentheses as a factor. Then I need to multiply all of this out to write the function. So I'm going to start by foiling the first 2, and then I'll come back in a second and foil the second 2. So if I multiply this out, this is going to give me x squared minus 2x plus 2x minus 4. And I'll come back in a second and collect like terms. If I FOIL the second 2, this is going to give me x squared minus 3x minus 1x plus 3. Okay, so let's kind of collect like terms in each set of parentheses and we'll talk about where to go from there. The first parenthesis, the two x's in the middle are going to cancel, so that's x squared minus 4. The second parenthesis in the middle, negative 3x and negative 1x, will combine to give me negative 4x, and everything else stays the same. So it's no longer a FOIL operation because FOIL has to do with a binomial times a binomial. We're just going to distribute here. So I'm going to distribute the x squared times all three terms in the second parenthesis. So x squared times x squared times negative 4x, and then x squared times 3. So when I multiply that out, I get x to the fourth minus 4x cubed plus 3x squared. Then I'm going to distribute the negative 4. So negative 4 times all three terms in the parenthesis. So negative 4 times x squared, negative 4 times negative 4x, negative 4 times 3 is going to give me negative 4x squared plus 16x minus 12. So then I collect like terms and I write the polynomial in descending power. So I'm going to start with the highest exponent. Highest exponent is x to the fourth. Then I would do my x cubes. I can put my x squareds together, and then my x's, and then my whole numbers. So the final answer here is going to be x to the fourth minus 4x cubed minus 1x squared plus 16x minus 12. So if I graph this polynomial, this would cross at 2, negative 2, 1, and 3. Okay, number 4, we're going to find all roots. And in this problem, the polynomial has already been factored for us. So when it's already factored, we just have to set each factor equal to 0 and solve from there. So x minus 3 equals 0, 2x plus 1 equals 0, x minus 5 equals 0. So this means that x equals 3. If I solve the second equation, that's going to be 2x equals negative 1. So then x equals negative 1/2. And then x equals 5. So those are the roots or the solutions to this polynomial function. Okay, number 5 wants us to find the number of turns, the number of zeros, sketch using the end behavior, and to approximate the zeros. So we're going to find out everything we can about this equation, and then we're going to graph it. So x cubed plus 3x squared minus 4x minus 12. First thing, I want to know the number of possible zeros. So that's the highest exponent, so 3. So 3 is the most number of times that it's going to cross the x-axis. Then we want to talk about the number of turns. So it's always one less than the number of zeros. So this graph is going to turn at most 2 times. Okay, then we want to look at the end behavior. So the highest exponent is 3, and that term is positive. So it's odd, meaning the ends are going to be doing opposite things, and it's positive, so it's going to be going up overall. So that means it falls on the left and rises on the right. Well, the next thing I'm going to do is actually find the zeros. So to find zeros, you want to factor the equation if possible. If you can't factor, then you'll just have to use your calculator to help you graph it. So this problem, though, is factorable, and we're going to use a technique called factoring by grouping. So I'm going to group the first two pieces here and see what I can factor out of them. So if you notice, they both have an x squared. So I'm going to pull out an x squared, and when I do, I'll be left with x plus 3. Then I'm going to look at the next two pieces. The next two terms both have a negative 4 in common. So when I factor out a negative 4, I'm going to be left with x plus 3. So when you factor by grouping correctly, what's in parentheses should always be the same, and it is here. So you're going to write whatever that is down one time, which is x plus 3. Then you're going to take the leftovers, x squared minus 4, and you're going to write it in a separate parenthesis. So it's factored now. We set each factor equal to 0, and we're going to solve. So if x plus 3 equals 0, then x equals negative 3. X squared minus 4 equals 0, so that means x squared equals 4. If I take the square root of that, that means that x equals the positive and negative 2, or the square root of 4, which is the positive and negative 2. So here's my three solutions, negative 3, positive 2, negative 1. Okay, so we're going to take that information and put it on a graph. I'm going to put negative 3, negative 2, positive 1. So those are the three places that it does something on the graph. And because each of those terms is only listed one time when we factor it, that means it's going to cross each time through these points. It's not just going to touch it, but actually go through those points. And then we know what it's doing on the ends of the graph. We said that it is falling on the left and rising on the right. So then it's just kind of figuring out the middle. You can type the equation into your calculator, hit graph, see what it looks like, go to the table and get some points, and then sketch your graph. So it should look something like this. You can see that it crosses at those 3 points, and then it falls on the left and rises on the right.